ladies and gentlemen, we're continuing Colloidal Silica Shark Week. Month. It doesn't sound as good. Colloidal Silica Shark Week month. What we're looking at this week is colloidal silica for durability. We've answered a question or two about how to use colloidal silica for durability. These next three videos we're going to focus on using colloidal silica for alkali silica reactivity. It's a huge problem that we have out here in the western US where there's a certain type of rock, sand, really aggregate that has a very specific form of silica that will react with the alkalis in our pore solution. And what will eventually happen is that we get this immature paste or immature gel that grows around the aggregate, and within that confined space between the aggregate and the hydrated cement matrix, it creates residual stresses that overcome the tensile and shear capacity of our hydrated cement matrix, breaking down the concrete from within. Here's a really nice picture of it. Ding! Ding! We are doing, what are we doing today? ASTMC 1260. We're not really running it per the ASTM. We have our 50% relative humidity conditioning room, but it's not very easy to move around in there with the camera and lighting, so this is a little bit safer. So please consult your ASTMs when you are running these, because we're just skimming over the procedure. The mix that we're going to use is prescribed in the ASTM.
Sorry.
You're fine. So 1260 and 1567, we are going to be running 1567 today. Modified version of it, because we are using colloidal silica, where we are using 440 grams of total cementitious, 990 grams of our reactive aggregate in the very specific gradation, and then we also have a high range water reducer and our colloidal silica. Now here's the thing, I like mixing colloidal silica in its raw state, but I normally do that with my larger particles or my modified particles. For the particle that I'm going to be using, it's one of the smaller particles that I've used, and it's more sensitive to agglomeration when you're putting it directly into the concrete or the grout for what we're going to be doing today. So in lieu of doing that, what I ended up doing was taking 50 milliliters out of my 207.8 grams that I was using for my water. So I took 50 milliliters out of that, and I added 0.5 milliliters of my high range water reducer, mixed that up, and then I added my colloidal silica. Now my colloidal silica that I'm using, it's at 24.25 ounces per hundredweight, which is around 1% replacement of my my cementitious package that I'm using, which in this case is just straight Portland cement. And we're going to be offering a calculator for that on our website here in the near future to give you a how-to or a quick how-to on dosing colloidal silica in your grout or concrete. So that's the mix that we're running today. Okay, so before I leave you off today, I wanted to go into why colloidal silica is great for ASR. And I spent about 4.5 years of my life doing research every day, doing research on the impact of nanosilica size and surface area on mitigating alkali silica reactivity in concrete. There's a 292 pages. 292 page document that covers that size and surface area impact. Goes into a lot of more depth and detail, but there's three basic ways that colloidal silica is going to enhance the hydrated cement matrix to mitigate that ASR. First, it's using up that pore water solution. The alkalis in the hydrated cement matrix in a fluid state are what are going to attack or consume that silica to create that very expansive gel. So if you use up or bind those alkalis in the backbone of concrete strength through pozzolanic reaction, using the colloidal silica, they can't act or react with that reactive aggregate to create that gel. The second way is by reducing the pore connectivity. And that's defined as not just the size of the pores and the amount of pores, but the connection between pores to allow a path for migration of other materials. So by using colloidal silica, we change up the hydration kinetics to reduce not only the amount of pores, but also the connection pores. And it's not just reducing them, but it's filling them with hydrated phases so that we can't have that water migration. So the third one is going to be accelerated cement dissolution, where we don't want to leave that much of the unreacted cement in the hydrated cement matrix. And by using colloidal silica, we're actually getting a higher degree of cementitious dissolution as well as an accelerated cementitious dilution. So we're getting more bang out of our cementitious buck, but we're also creating more of those hydrated phases that are going to stop water migration as well as bind up those alkalis that would contribute to alkali-silica reactivity. Overall, we're creating an environment that does not allow that alkali-silica reactivity to thrive and survive. The biggest thing with colloidal silica or with alkali-silica reactivity is reducing the migration of alkalis and those reactive alkalis that can bind with the silica. And that's ultimately what the colloidal silica is doing, is densifying and securing that entire hydrated cement matrix to make that concrete stronger and last longer. I'm pretty excited for our next set of videos. Please stay tuned, and if you have any questions, throw them in the comments section below. Go concrete, beat asphalt!